the inverse functions, and given g of x, I am to algebraically find the inverse function. So if you notice, I have attached this. From this, it may be easy to see that I'm looking for all x's greater than or equal to 0. So in other words, I'm just getting one arm of a parabola. The vertex of this parabola is -4 to infinity. I digress. Let's go. I'm going to algebraically find this. So very simply, I'm going to write y is equal to 3x squared minus 4. I've just simply done a simple substitution where g of x is equal to y, just to make it easier on my brain to compute. Then I switch the x's and the y's. Now, it's my job here to isolate. So here, this is an important step. So I switch x's with y's. Y's with x's. Now, I need to isolate for y. Now, this might take some time. So I certainly hope I have enough space here. So very simply, I'm just going to add 4 to both sides. I think it'd probably be easier to keep y on this side, try to throw everything over on the other side. And then I'm going to divide both sides by 3. And that is y squared. So I have y squared is equal to x plus 4 divided by 3. Next thing I'm going to do, now this might, how do I undo squaring? That is, I have to take the square root of both sides. So if I take the square root of both sides, my final answer is the inverse of g is going to be the square root of x plus 4 all over 3. Make sure that square root goes all the way down to indicate that it covers the 3. Now, we're only going to consider the positive root here as a technicality. If we were in person, I would definitely explain this more thoroughly, but you'll probably get a taste for why this occurs on Thursday and Friday. All right. This is not fun. It is full of tons of hiccups and stuff. However, press pause, have a go at it. Try your luck. You're joining me after your pause? How did that go? I'm going to start off by saying y is equal to x divided by x minus 1. Just simply replace my x's with my y's. Mr. Morin, must I include this restriction? Well, really, this restriction was put there by me because I cannot let my denominator equal 0. It really has little effect on it. The next step I'm going to do is I'm going to replace the x's with the y's and the y's with the x's. Right about here is where the wheels fall off. So replace the x's with the y's with the x's, and what do you do when you have two y's? Great question. I'm sure that most of you guys had an issue with that. So here, I'm going to multiply both sides by y minus 1. So if I multiply this side by y minus 1, all I'm left with is y. one way to keep equality in the equation is what you do to one side, you do to the other side. The next thing I'm going to do is I'm going to multiply out this expression. So this turns into xy minus x is equal to y. Now, if you were able to do this, you're a superhero. How do we isolate for y? Wow, there's two y's. That's what makes this so complicated. The key is to put all the y's on one side, move the x over to the other side. Do you see it yet? Key, as soon as I write down this, everybody's going to say, oh, the key is to factor out a y. So really, whenever you struggle with the idea of two y's, try to put them together and factor out a y, if it's possible. Really helpful strategy. So then, y is not isolated, so I'm going to divide both sides by x minus 1. So my inverse function, now this is goofy by all means. My inverse function of h is x divided by x minus 1. You may be asking yourself, we did all of that work? Compare the inverse function with the regular function. They're actually the same. So h is a function such that it undoes itself. Very, very, very strange. So I'm just going to go over this ever so slightly. What is the range of this? That's a great question. Now I'm going to, since we're in the neighborhood of difficult questions, I'm going to ask you what's the range of that? And you might be saying, that is a crazy function. I've never seen a function like that. So how can I know the range? Well, the range for the inverse function, if you work your way backwards, was the domain for this function. So I guess if you know the domain of h of x, you know the range of the inverse. Going back to the first lesson of functions, the domain here, x is element of the reals, except for x cannot be equal to 1. In other words, we only have one value that does not work in this function, and that's where x is equal to 1. Just for fun, I am going to write it in interval notation. That's how I would do it. That's my domain. That's a description of all the x's for h. The description for all the y's for my inverse are going to be the same. Now, this wasn't a part of the original question, but definitely it's really fascinating that sometimes in math, the information is already given to you. You just have to look for it in a creative place. Hope this helps. We're going to move on to our next example very, very shortly.